Hello everyone, welcome back to GeoMicrosphere. In today's video, I'm going to show you the quickest and the simplest way to process Sentinel-1, that is synthetic aperture radar image, and then export it to ArcGIS Pro or any GIS software for further analysis. So here we have the software here called Snap, that is the Sentinel application platform where you can process the radar image, which it must go through some process, which we have the orbit, upright orbit file, thermal noise removal, calibration, and then the other. So this is the software that we are going to use to do this correction. So if you want to download this the software, is very simple, and then I will leave the link in the comment section or in the description of this video so that you can go there and then you download and then you install. It's very simple for you to install. So this is the link here. So you can see we have step.esar.nt.main.download. So if you come here, you can click on open here, and then you download this one here. So let's quickly begin. So first of all, before you can do this, you need to download your Sentinel-1 image, which is a radar image. So you go to Copernicus browser, you can download your Sentinel-1 image there, and then I will make a video on how to download Sentinel-1 image so that you can watch it and then you download it perfectly. So first of all, let's load our image. So to load your image, you go to file, or you click on this button here, open product here. So you can click here, and then we are going to open project where we have saved our Sentinel-1 image. So let me quickly, okay, so here I have my image here, which you can see I have my this is the zip file that I downloaded. So here we are going to load the zip file. So if you download the images, it will come in a zip format. So here you can download the zip, and then or you can upload the zip. Sorry, you can upload the zip here. So you click on open here. Alright, so here you can see we have our image here, which is 2020, which the image was captured in 2020 December 12 here. So you can see the image date here, and then the products, and then the property. So you can open here, we have metadata here, which we can click on it and then open it. So here you will see the properties of the image, the acquisition mode, mission, and then the processing time, the real orbit, and then the state vector time, and then the everything. So here you see the properties of the image, the coordinate, and then everything here. So you see it here, and then here the product type is GRD, and then the product is Sentinel-1 here. So you can see all the product, and then the vertical and then the horizontal here, that's the band which is inside here. So we are going to explore the band and see. So let's click here. So here we have amplitude vertical, and we have amplitude horizontal here. So the VV is the vertical, and then the VH is the horizontal. So here we can double click on one of the image, and then see how the image will appear. So here we can visualize the image before we perform our corrections and then export it. Alright, so it's going to take a few minutes or a few seconds for it to open, which we can view our image. Alright, so as we are waiting for our image to open, let me show you this. We have two ways to correct for the error. Either you do it step by step, or you can use a model builder to do it. That's one tool is there. So I'm going to show you the model builder one and then the other one which you prefer to use, so that you will see which one is the simplest and then which one is complex, so that you choose from the two. So here you can see we have the image here, which alright, so this is our image. This is our Sentinel-1 image here. So you can see all the black portion here is a water body, and then the other class. So this image is not corrected. So here we are going to correct this image that we see here. So to correct for this image, we the first step is we need to apply our orbit far. So here you can go to radar, and then you go to geometric here. Right, so let me see. Okay, alright, so let's first of all let's use the graph builder before we come to this one. So let's go to the graph builder here. So to go to the graph builder, you go to tools here, and then you click on graph builder here. So inside your graph builder, you are going to build a model which is going to correct for all the errors. So here you can see read and then the write. So the read is the image that we downloaded, and then the write is where we want to save it. So we are going to add the rest. So first of all is we need to apply our orbit file. So to apply your orbit file here, you go to read, you right click on read, and then you go to add. So on your add, you see input, output, optical, radar, raster. So you go to radar here, and then you go to alright, so let me see. Alright, so you go to radar, and then the last one you see apply orbit file here. So you click on apply orbit file here, and then you position it, and then you see you put your cursor here. You see a red button there, and then you drag your cursor to the apply orbit file to connect the read and then the apply orbit file here. So here you can see I have connected my image here. So the read is the image, so I have connected it to this one. So I'm going to perform apply orbit file on the image here, and then the next step is thermal noise remover. So that one, to you right click on apply orbit file, you go to add, then you go to radar, then you go to radiometric. You see apply thermal noise remover or thermal noise remover. You see it, you click on it, then you drag it to, and then you connect it to the apply orbit file here. Alright, so the next step that we are going to do is calibration. So after performing your apply orbit file, perform thermal noise removal, the next step is calibration. So you right click on it, you go to radar, and then you go to radiometric. So on your radiometric, you are going to see calibration there, then you click on calibration, then you drag it. Alright, so now we have our apply orbit file, our thermal noise, and then our calibration. So it's going to follow in that order. So the first step is apply orbit file before the thermal noise, and then the next one is the calibration. So from calibration, then we move to terrain correction. So after performing your calibration, you move to terrain correction, which I will explain each of them into details for you. So the next step is apply terrain correction. So right click on calibration, go to add, then you go to radar. So inside radar, you are going to see terrain correction. So you go to radar, and then you put your cursor on geometric. Inside geometric, you will see terrain correction here, then you choose terrain correction from the drop down. Alright, then you connect calibration to terrain correction here, and then the next thing is linear to or from dB. So linear to or from dB is that we are converting our intensity or our amplitude VV into a dB, which we are going to use it in the ArcGIS Pro. So you right click on your terrain correction here, then you go to add, then you go to raster. So this time we are not going to radar, this one going to raster, then you go to data conversion. So inside the data conversion, you are going to see linear to from dB, then you click on it, then you connect your terrain correction to your linear DB. So after performing the terrain correction, it's going to convert to linear to or from DB. So from linear to DB, then you connect it to the right. So the right is where you want to save it. All right, so now this is our builder here. So first of all, you read, then you apply, you remove the noise, then you calibrate, and then you perform your terrain correction, you linear to or from DB, and then you write. So first of all, let's go to write. So you can see all the process that we are using here is under here. So here we are going to go to write here. So inside your write, that is where we want to save it. So this is the name, and then here if you want to change the name here, you can change it like this. Then you go to apply orbit far. So here you don't change anything, you maintain it like that. Then you go to thermal noise remover, that one to you maintain remove thermal noise. Then you go to calibrate. So inside your calibrate, the output sigma, and then the output beta band, you can check any of them. So here let's maintain output sigma, and then we go to our terrain correction here. So inside our terrain correction, click on your map projection, you double click on it, and then this one will open here. So here we are going to set the coordinate system to our local coordinate system here. So you go to projection. So projection is where you are going to project our coordinate system from the global one to our local one. So here you click here, and then you go to the UTM. So you can select UTM zone, then you set your own zone, or you can select UTM zone automatic. So the automatic will set it automatic for you. So let's click on UTM WGS 1984 automatic here, and then click OK. So here you can see my location is on zone 30. So you can see it has automatically load for me. And then the last one is linear to DB. So here you don't change anything here. And then the next step is you run it here. Alright, so now let me explain each of the steps for you. So let's start from the read. So the read is what I just said, the image that you are going to load, and then the next step is apply orbit file. So the apply orbit file improve satellite position and then the timing accuracy. So after performing the apply orbit file, you are going to improve the satellite position and then timing accuracy. So if there was any distortion in the time, this is where you are going to correct it. And then we have the thermal noise remover, remove additional noise introduced by the sensor electronics. So maybe when the sensor was taking the image, there was some external variables which come in contact with the satellite. So when you perform the thermal noise remover, it's going to remove any other noise from your image, so that you are going to get a clearer image. And then also we have calibration. So the calibration is to convert raw digital numbers to physical meaningful bar scatter values. And then we know satellites normally take images in digital numbers. So here the calibration will convert the digital numbers to physical and then the meaningful bar scatter values. Alright, so and the next step is the terrain correction. So the terrain correction introduces the radiometric distortion, radar bar scatter, and the stronger effect by slope and orientation. So the terrain correction correct for the terrain, the slope, and then the aspect of what we are doing. And then the next step is we have the linear to DB. That's what I just explained. So convert bar scatter values from the linear scale to decibels. That is where we can use it in the ArcGIS Pro. Alright, and then the right is where we want to save it, as I have already said. So this one you are done, and then you can see down here we have graph initialize. Okay, so here the graph initialize. Okay, where we can click on run and then run. And then let me tell you, this may take more time, maybe 30 minutes to 1 hour to run successfully, but for time's sake I have already done one. So let's open it in ArcGIS Pro and then see how it's going to look like. Alright, so here I have my ArcGIS Pro here. So let's load the image here. Alright, so I have my image here. Alright, so let's load our Sigma VH and then our Sigma VV here. Alright, so it's going to load. our image is going to load for us to see how it's going to appear in ArcGIS Pro. And then if you want to perform either flood mapping or any analysis, you can use your study area to clip a portion of your study area. So now you can see now our image look clearer, as you can see here. So here you can zoom in and then see where the water bodies is, and then here you can put your study area or your study area shapefile on it, and then clip a portion of the image, which you can use it later. So this is the simplest way to perform your correction on your Sentinel-1, that's the SAR, synthetic aperture radar image, and then export it to ArcGIS Pro. So here, let me show you this. So here, after running, and then after running, everything is going to save into your folder. So here, if you where you say you choose your location here, then here too, if you want to change your location, you can click on this button here and then change the location. So after everything, you can go to your folder, and then we are going to see like how I showed you. So this is how it's going to be: Sigma VH and then the Sigma VV. All right, so thank you very much for your attention, and then please if you have any question or any concern, please don't forget to leave it on the comment section, and then please don't forget to subscribe, like, share, and then comment. Thank you very much. See you in the next video.